Yeah, I do have one on YouTube, but it's kind of old, right? So thanks for that. Yeah, man, there's so much I could just explain to you all, but let's read a bit, right? And say if you have your pen or whatever, there's a lot of things here, like vibration actually enters your body on three planes, right? Or three dimensions, right? Like sound would have just entered the body, like through the air, vibration. Like remember, human beings are 3D, like we are 3D person. So vibration enters you then on all planes, if you want to put it like that, then. I'll explain it a little bit later on the slide, right? As I mentioned to you, there's lots of um, medical benefits of vibration, sound, music, frequency. There are lots of beliefs on this, not just, like weird stuff now. Remember, I think I told you all my introduction to this happened at Neil and Massey. Long story short, you all must have heard about the experiments with water, scientific experiments. And I could do it right here, I could show you, but I have to be able to show you like over the screen. Where if you have a flat surface like a glass and you put like grains of salt on it or something fine, I'm thinking salt maybe kind of large, but something really fine. And if you play quiet music, if you play um like Mozart's then, right? You could actually see whatever you put on that flat surface, like if it's a glass, you'll actually see it organizing itself. And if you play lots of disruptive music, you're gonna see it looking disruptive. Of course, many experiments have been done on this. I'm sure you're all aware of it, where they have like your voice, then your voice, your words are also vibration, right? You could just put your hand here, you could put your hand here. There are certain vowel songs. If you say A-E-I-O-U, you'll find different parts of your body would actually vibrate. I don't know if you know that. I could actually do some for you all, but it probably wouldn't be this class. If you say the letter A, you say at the E, you'll find like your temples and stuff vibrating. So human beings, we live in a 3D world. We are also vibration or vibrating, and we are also a form of vibration. And with the one with the water experiments, anybody know where I'm going with that? Like where they would have played good music to water and they look at the water under like a high power microscope, you'd have seen the water crystal or the water molecules, it organized itself into beautiful patterns then. But if you would have said, like your cup of water, and you said to this cup of water, well, this is just not good. Blue waters is not good, or Dasani is not good, right? And you look at the water now under a microscope, you'll see it that like the crystals in it look distorted, right? So the whole thing of that, if you all have heard about this, is that remember the human body is also water. So maybe what do you say to yourself, right? Do you say to yourself that you can get this qualification? Do you say to yourself, like what do you say to yourself then? Because those are the things that form who you are as well. So vibration is not just lesson then, right? Like I said, there's lots of things about this, and maybe I think is it Bob Marley had a writing when he said good vibration or good vibes. So maybe he had that from back then, even without the scientific experiments anyway, right? Um, so when the whole body is supported on a vibrating surface, the term whole body vibration is used. I'll leave out some of this because I think it's easy. You also have something called hand transmitted vibration. It's a form of local vibration occurring when the hand is directly in contact with the vibrating surface. Example, in the use of a handheld vibrating tool and equipment. In certain circumstances, when driving, an individual is subjected to both local, which is hand transmitted vibration, and whole body vibration, right? So vibration is best understood as being an uh, oscillatory motion to and fro between 2 points. You could watch your book and you may see some of this in the meantime, right? The direction of this motion varies with time. The degree of oscillation determines the magnitude of vibration, and the number of oscillation is given, sorry, in a given time is the frequency of the vibration. Thinking about this, explaining it to you all. Anyway, so vibration in any form, if it is an academic form or just how it is in nature, you see then like there is, when they say an oscillation, and it's like going up and it's coming back down. It's going up and it's coming back down, right? So there's a period of acceleration, there's a period of rest, there's a period of deceleration, there's a period of rest, there's also a period of acceleration again. And This is actually just how energy is. Vibration in its purest form is a form of energy. It all kind of follows, if you look at that, it all follows like what they call the DNA structure, all of that, right? All of that is still, the same sort of up and down. Later on, you'll see, if you all remember doing any maths, they call this, well, sine or sin, right? That's the frequency that we are in. So there's not a religious class just to tell you that, but that's the frequency that you are in Earth. All of us here for now. We won't always be here, but we're here in Earth for now, and Earth is the sine frequency. That's the frequency that you're in. If nobody didn't tell you that. Abbreviated, they say sin. They say that you are in sin, but you're really in sine. Sine is, well, sin is short for sine. You check it out on the calculator. This is the frequency that you're in anyway, right? We are in the sine frequency. As I told you last week class, and have devices you could use, dogs or whatever could hear other things out there, the other frequencies that exist. But human beings, we are in the 3D, we are in that sine frequency. If you do maths, if you remember doing maths, and you plot a sine graph, you'll get the same thing. If you plot a sine graph, if you do this as CXC, you'll get the same thing, right? No matter what maths you do, if you plot, you work at the equation and you plot the points, you get back the same thing. That's the frequency that you're in the sine frequency, right? As I have this up, what I could tell you, I could probably tell you some things here, and I do feel none of this is your exam. As I was telling you, I was thinking how much to do and how much not to do, right? So like, maybe we could pinpoint some things here, right? So like, what you're looking at here, this is like the amplitude of sound, right? So like the top of the curve, if you look at from the point of displacement to the top, that's called the amplitude, right? If you want just kind of have an idea, but that's called the amplitude. One full up and one full down is like the magnitude. You said like what's the magnitude of sound? If you were to graph it out, one full up, one full acceleration, then and one full deceleration is the magnitude, right? And the number of complete cycles you have in a time is called the frequency. Let's put a time here. So let's say this was 1 minute. The time is normally in seconds, right? When they do a frequency curve, time is in seconds, right? So let's say this was 10 seconds here. The number of complete cycles you get in that time is called the frequency. The frequency then we can say is this is one complete, that's one cycle there, and this is another one. So the frequency here is 2, right? The frequency, you have 2 cycles in a certain time. So the frequency is 2. I don't think you need to know all of that, but keep some of the bigger concepts in there. Like when they say you calculate the magnitude of vibration, that's one complete cycle then, one up and one down. Some people say one birth and one death because it's like an acceleration and a deceleration. You make one cycle, right? One up, one down. That's called the magnitude, the size of the vibration, right? So are you all seeing this in your book? It's right here into 12.1 and all, right? Frequency, amplitude,
Okay.
displacement, velocity.
In your book, I am seeing where I would say the 2 up is from the middle to the middle. I'm seeing a cycle. Could you explain that for me?
Yeah, the same thing as a cycle. Yeah, well, remember, it wouldn't just be 2 up. It would be a up and a down and then a up again. So yeah, they call this like, this is actually referred to as like a cycle or a wavelength, right? That's like your wavelength. But remember, it just go up to up. I think life is like that, up and down and up and down and up, right? So one complete, if you see between 2 here, you see one cycle, because this here, the person would have completed a cycle then. If you say like, if you measure it in terms of that, so there's one complete up and one complete down, right? But if you look at the 2 wave, what they call like the zenith of the wave, then the top of the wave, the magnitude or not the magnitude, the amplitude of 2 points, that is referred to as one cycle, right? You make a cycle, right? All right, folks, have a read of it. So the beauty about this thing is that it is an open book exam. Nothing is really, too far from you in terms of that knowledge. What I would like to propose though, I would like to bring it back a little bit to some words that's on the other slide, right? And maybe the units for vibration. So if you come back here with me a bit, right, what you'll notice is that what I was saying before now, there's a period of acceleration and there's a period of deceleration, right? Now, in terms of vibration or in terms of physics, there's a unit for that, right? So the unit for vibration, if you want to write that down, is meters per second squared, which is the same unit for acceleration or deceleration. You could put it ms to the minus 2, or some people write it as ms slash 2 meters per second squared. The reason for this is because it actually have a law for vibration in health and safety, and they give it a figure, like how it have for noise. Then remember noise? What was the noise values? Anybody remember the noise values? Noise values was what?
83, 85, and 87.
Well, not 83, but yeah, okay, we're close on two of them. Anybody else?
80, 85, and 87. 87 is
Right,
the
80,
max.
85, and 87. So yeah, so there's a law for vibration passed in the same year, 2005 in the UK. And there are some units for vibration that you're not supposed to cross. And they did it for the both types of vibration, hand arm vibration and whole body vibration. I can tell you now, but I'll leave it for the book, right? Because I can tell you now, I don't know if you want to write it down now. But what I say now, the units expressing that is the unit for acceleration and deceleration, right? If you do physics, acceleration, deceleration is the same unit, ms to the minus 2. So for vibration, they also give the figures in ms to the minus 2 meters per second squared. You see how interesting this part of it is? That's what I'll tell you. It's so much, to me, I find it so interesting, but it's also how much of it will come for you. And that is the give and take with this. And I said, because it's an open book exam, I didn't want to do all of the formulas. There's actually a formula and stuff for that and a formula for velocity. I think one of the formulas is a formula for acceleration, right? All of that is here. So I wouldn't read this, but let me read one for you. What I was trying to tell you here is what was happening, right? So assume the object starts from rest at a position of maximum displacement. It begins to accelerate towards the equilibrium position from which it has been displaced. So an object starts from rest. This is just how it is found to be in nature when you measure vibration, right? It starts from rest. It reaches that point of equilibrium. No one knows what causes it to go back down. So I think scientists say it's just the force be with you or God, but this is just how this life is, and this is just how this reality is. Like it would reach a point, it's actually equal in it. Equal go up and equally come back down. Like I said, you could plot any maths graph, something called a sine curve. You're going to end up back with the same thing. Whatever numbers you work out, it ends up to be the same thing, right? So it overshoots the equilibrium position at its maximum velocity and begins to decelerate due to some restraining force. The restraining force is what scientists don't know what it is. It's just life, right? Until it comes to rest at the maximum displacement in the opposite direction. The restraining force then begins to propel the object towards the equilibrium position again, and the process is repeated, right? At the equilibrium position, displacement is 0, velocity is greatest, and acceleration is 0. Now, again, this is the physics here. This is at this position here, right? At this point here, at the point itself, when I say point, where am I mark? If you say the point itself, at this point here, right? This is like displacement, right? This is like where displacement here is, of course, like 0. But at this point then, what they say here is like, like acceleration at this point is 0, right? But this have the velocity, this have like the speed then. Velocity is another word for speed to get up here anyway. But at this point, it's 0. Acceleration at this point is 0, right? This point here is like what we call the point of rest anyway. All right, let's see. So vibration amplitude is the extent of vibration from one point of rest. In other words, it is the difference on the sinusoidal wave. That is what you're looking at. This funny looking thing here is called a sine wave. This is how this life is. From 0 to the top of the peak. So I told you that before, amplitude is from the 0 to the top of the peak, right? As the amplitude only considers the vibration in one direction. But if you compare a complete up and a complete down, that's called the magnitude. The magnitude of vibration considering the vibration in both directions is a more useful indicator, and actually that's how they measure, in this case, vibration anyway, right? Vibration magnitude during the oscillation of the vibrating object, it alternately has a velocity in one direction and then in the opposite direction, i.e. it is constantly accelerating. There's a formula for this. Acceleration is equal to the range of change of velocity, which is the change in velocity over the change in time. The dv over dt, that's a word from maths or even physics. I don't know if anybody ever did it. dv over dt. It means change in velocity over change in time, right? Do I try to show you one? Again, I tell you this thing maybe. So, like if you check in the acceleration, it's change in velocity over change in time. So what you'd have had to say, they normally refer to this as like V1 and V2, right? So the change in velocity, the formula for that, which is dv over dt, is said to be V2 minus V1, right? Nobody will give you this enough. And then the change in time, if you're checking it at this point here, will be, you gotta get the time, of course, from the graph, right? It will be T2 minus T1, right? That's what is said to be change in velocity over change in time. So if we say here is 0, V1 is always going to be 0. T1 is always, sorry, this is T2 minus T1, right? My mistake here. So T1 is always going to be 0 as well. So if we say this up here is 10, just saying 10, right? 10 meters per second squared. This would have been 10 minus 1, which will give you back 10. And if we said down here was also, let's say 5 seconds, because a complete wave, we said, we put 10 down there. So let's say this is maybe 2 seconds then, right? So then it'll be 2 minus 0, which will give you back 2. So the acceleration is going to be 10 divided by 2, which is 5 meters per second squared, right? It's a bit of odd maths right there. But just trying to explain this slide, right? dv over dt. I kind of forget what that actually means in physics, or those of us who did maths, and if anybody did it recently. I think the word is, can't remember the word, right? But I know the formula, right? dv over dt, and I know what it stands for, but there's a type of maths that the dv over dt is a type of maths, right? I think they call it deviations, right? Deviation in maths, right? But the formula for acceleration, change in velocity, that's how you interpret it, change over time, right? So first in one direction, then in the other. Consequently, the magnitude of vibration can be quantified by either its displacement, its velocity, or its acceleration. I'll leave in some of those formulas there, right? For technical, practical reasons, the acceleration A, and that's part of the formula, of this motion from the maximum point or peak in one direction to the maximum point in the other direction is the usual unit of measurement. The instrument used to measure vibration is called an accelerometer, and the units of acceleration as per meters per second squared is ms to the minus 2, or ms/2, right? Well, the 2 to the top. An indicator of the average of these acceleration can be obtained by calculating what is called the root mean square, RMS, which is a common measure of damage potential. So what that is, if it's not here, I think it's here though. Yeah, here, let me read it from here, right? So since the acceleration changes in the sinusoidal manner, which is up and a down, the sine frequency that life is in, the magnitude of vibration is taken as the average measure of the acceleration. For sinusoidal motion, the average value used is the root mean square. The term is ms to the minus 2, and this is the maximum acceleration you get divided by the square root of 2. So if we had gotten 5 to be the acceleration and they asked to calculate the root mean square, you take 5 and you divide it by the square root of 2. All of which I don't think ever come in, but it's all good stuff anyway. Tell me if I get it a bit. Right? What we work out here, this is acceleration. Change in speed over change in time. If from the acceleration, if ever, they say, which I don't think they'll ever do, right? I would never see any questions like that. To calculate the root mean square, you take the magnitude you got, the acceleration you got, which is letter A. A is a symbol for acceleration. and you divide it by the square root of 2, right? You see what I tell you, I was deciding when I started the lesson how much of this to kind of go through. All right, vibration frequency. So this is actually some good stuff again. The frequency of vibration is expressed in cycles per second or hertz, as used for noise measurement. The relationship between displacement of an object and its acceleration depends upon the frequency. For a given displacement, the acceleration would increase as the frequency increases. Vibration direction. So with complex vibration objects, there may be vibration in all 3 dimensions. Remember, I mentioned that a bit at the top. We are 3D. Not everything affects us in 3D. Like noise then doesn't affect us in 3D, but vibration does, right? And like I said, there's a lot of things on that where people do therapy and stuff for injuries and past injuries and stuff, back pain, right? With vibration then, right? And I mean, I think even simple things like acupuncture may have been some aspect of that, right? Not quite that, but I think even things like that may have been some aspect of trying to channel vibration, into certain parts of your body that may cause pain then, right? But vibration enters the body in how the human body is, which is a 3D body, right? So vibration is usually measured at the interface between the body and the vibrating surface. For handheld vibrating tools, the vibration can be along the axis of the shaft or at each orthogonal, mutually perpendicular or right-angled axis. And that is, they're talking about the 3 planes of vibration there, or the 3D dimension, right? So for whole body vibration, I'll show you just now, just give me a couple of minutes, right? For whole body vibration, affecting a seated person, the vibration direction are fore and aft, side to side, lateral and up and down. And that's like 3D. It's kind of like your hand. You see, if you put your hand, these 3 fingers, if you put these 3 fingers down, that would reflect the 3 dimensions that vibration can enter your body, right? Like that. So you have like the right angle here. I guess I have to hold it up like that, right? Have the right angle. You can try it for yourself and see. You have the front and you have the fore and the after. It's on a picture coming up. So if you didn't get it from that, you get it from the picture. The point is here, vibration enters the body on all planes, right? Let me try to clean somebody's slide. Um, when I did my master's, right? Yeah, when I did my master's, there wasn't any study on vibration in Trinidad, so I did one. And I think that was the only one it have, right? In terms of workers in Trinidad being exposed to vibration. Just now, get rid of something from on top there as well. There are lots of studies on noise in the country, but not any on vibration. What I found though was that, I mean, a long story short, what I found though was that everybody had liked to do, and all the folks in the UK had liked that study. But what I found was that there was no association between vibrating tools and like vibration-induced illnesses in the Caribbean then, right? So I think my study went down as what you call a confounder. It didn't support the views of the other researchers then, or researchers that vibration was linked to some of the vibrating illnesses we like we have then, right? And the reason for that, anybody could speculate the reason for that. I guess we have to do the whole course and then you figure it out, right? Well, a lot of I guess when we go, you'll see. So I kind of leave that there. I'll leave it there until maybe we finish the course. I'll come back and ask you the question again. Why isn't it that a lot of people in Trinidad, maybe we just good people, maybe we just have good circulation, or maybe we just have something else that is good, which is obvious, right? Sample size for data too small. It was a fairly big sample size, right? But what does the Caribbean have that? I mean, we have lots of things, but what do we have here that you think could have affected that study a bit? if you know a little bit about vibration, right? Heat, yes, the answer is heat, right? Vibration illnesses are triggered by the cold. You know, like when you're feeling cold, right? Your blood sort of flow lower down, you know, in your, well, I guess in your capillaries and stuff, right? But the Caribbean is sort of warm then, right? So a lot of the vibration illnesses are brought on by the cool. Well, when the temperature is like 11, 12, 5, 3, but the workers are using vibrating tools. So a lot of it is triggered by that. So there wasn't an association here in the Caribbean found between, workers who are using vibrating tools. Anyway, back to the side. So you see the three sort of, the three dimensions. Now, again, you don't have to remember to draw nothing. This is an open book exam. But these three planes then, the three planes that vibration enter your body, right? You can think of it, I just trying to be simple, but folks, it's not always simple, right? You could think of it as vertical, horizontal. Like this one could be classed as horizontal, couldn't it? If you were to extend here, this could be said to be horizontal. This, if you go up, could be said to be vertical, and this could be said to be perpendicular, right? But even though if we use those words in the world of vibration or the world of energy, then you can refer to them as the X, Y, and the Z axes, right? So vibration would affect your body, like your hands this way, and of course, perpendicularly as well. Somebody who is sitting, right? Somebody who's driving a vehicle or sitting on a vibrating platform, you see it enters the body in the same three planes as well, right? So again, we could say, vertically, horizontally, and perpendicularly, right? And like all parts of your body then. So vibration affects you. And of course, if you look at the book, if you look at page 212, they give you certain frequencies that may affect the body. 0.3 hertz, motion sickness, 1 to 2 hertz relaxing. So that's just saying a lot of science and a lot of research have gone into now, like the healing properties of sound and vibration then, right? Whole body, 20 hertz, tingling, right? So the point is we are affected by music, as you all know, and we also affected by vibration. But like a lot of research is now going into like good vibration then and the effects to the workers. Of course, this course doesn't cover that, but I just wanted to say that because we can't make look vibration bad all the time then. I mean, yes, it's occupational health and safety, but there's also good properties that they could actually harness that frequency range and be able to assist workers who may have had back pains and pain through their bodies, etc. Right? So this slide touches on the law, the control of vibration at work regulations, 2005. Just like noise, there's the control of noise at work regulation, 2005. Vibration came along right around that same time. Right, the regulation came into force the 6th of July 2005, and they have limits for vibration. Let me see. If it's not on this slide, I could shout it to you, but it's on the slide, so wait a bit. Don't write it down a bit. I'll just say it for you. But wait till it come up on the slide, right? So they have limits for hand-arm vibration. Like there's a limit. If you measure them, the hand not supposed to be exposed to that amount of vibration, right? And they have two values, just like noise. Unlike noise though, I mean, noise have three. They just have two values. They have one action value and they have one limit value. Just try to listen to it. You'll see it on the slide coming up just now, right? So kind of similar to noise, but noise have three values. For vibration, they have two values. They have like an action value for hand, and it's actually 2.5. It's easy to remember. It's 2.5, but you don't have to remember nothing because you're a book exam. And for the limit is actually 5 meters per second squared. So for hand-arm vibration is 2.5 meters per second squared and 5 meters per second squared. So if you ever do a participant, they say they measure and they got 3 meters per second squared or they got 2.5 meters per second squared, then you are on the action value, right? You're on the action value to reduce it, to take steps then, to turn off the machine, to make sure the workers are wearing a glove, right? You're on the action value. But if you cross 5, you breach the law, and then that means money. That means you have now, contravene the Controller Vibration at Work Regulation 2005. And the penalty, as you all always know, is £20,000 minimum, right? I'll give you the one for whole body vibration coming up. Please, you don't have to write it. It's on this slide. I just say I'll short it for you so that you know it's a real figure, but you'll see them coming up on this slide just now, right? All right, so hand-transmitted vibration, exposure of the fingers or hand to regular and or prolonged vibration can result in circulatory vascular disorders. And the worst of them is called vibration white finger. And I'll tell you why in a bit. And yeah, you probably saw the picture anyway too, right? We have neurological disorders, numbness and tingling, muscular effects, difficulty to grip, reduced dexterity. And that is like the ability to move your last digit of your fingers, but to do like some simple tasks, but like skill tasks. So simple things then like fastening your buttons on your clothes. That would be a problem if you have vibration white finger, right? So that's like one of the obvious. Remember when we did noise-induced hearing loss, they say you couldn't hear, consonants. So this is like one of the side effects on a vibration white finger. Simple things then. So like I suppose you could be able to use a phone, but you mightn't. I mean, not as if you have to feel what you're pressing, but things that involve using, like if you had to thread a needle, fasten your buttons, those are the things that become a problem with reduced dexterity, right? Articular effects, bone and joint problems, hand-arm vibration syndrome. The most common ill health effect is vibration white finger. So let's read it out, right? Vibration white finger first reported in 1911 in Rome by Professor L. Loriga. For many years was described as a Raynaud's disease or vibration syndrome. Got some background noise. Right. In 1970, the Industrial Injuries Advisory Council termed the condition vibration-induced white finger. The frequency range over which injury can occur is believed to be between 5 to 2,000 hertz. Lower frequency, keep this one in mind, 5 hertz to 150 hertz are considered the highest risk. Keep that in mind if you're going into exam, right? Because they can actually tell you, like they measure and they got between 5, maybe they say they got 150 hertz or they got 10 hertz or 20 hertz. But say lower frequency ranges could give the most common risk of vibration-induced white finger, right? Apart from frequency of vibration, amplitude is a contributory factor. Remember, we had that out here. I took it off. Can you tell me what amplitude is again? What is amplitude? If I had, because we spoke about it already. What is amplitude? Is it magnitude? And then what is magnitude? What is amplitude? How high or how low? Or what part we had to draw here to draw amplitude? Anybody? We have 17, 18 persons.
Amplitude is the highest point.
Right,
Magnitude is the whole.
Yeah, very good. That's it, right? So the amplitude of the vibration then determines, so the amplitude, and this is what they're saying, like how high it is, right? So let's just put here like 10 hertz or something, right? So the amplitude, right, of the vibration is a contributory factor. Increased amplitude increases the potential risk. But for this one here, they say it is believed to be, around 5 to 2,000 hertz. And then the lower frequency ranges are the ones that sort of, could give rise to vibration-induced white finger. Let me change back the marker. Right. Let's go again. So vibration-induced white finger symptoms in the early stages. Just now, huh? Okay, I think I'll explain all of this in one. Because like what is really meant by early stages, right? So let me know if you're ready. I'm going to try like a explanation of 3 or 4 slides here in one, right? So the explanation is this, right? How would they measure, or how a doctor will assess you for vibration white finger is they would look at your hands, of course, right? So they look at your hands and they look at a chart. In other words, then what I'm saying, they don't have like a piece of equipment. The equipment would have been used to measure vibration, like in the workplace. If you use an accelerometer, right? That would give you like 2 meters per second squared. But a doctor wouldn't, when you come to a doctor then, right? When you come to a doctor in the doctor's office, like I guess if like if it was your lungs that you're going to check, maybe for an infection, they would take like an X-ray. They could probably have you do something called a vital capacity check, which is where you blow out into a spirometer, right? But what I'm trying to tell you is that for vibration, the doctor don't have anything like a piece of equipment then. Think you understand that? The doctor don't have no way, they don't have anything to like measure when you come to the doctor. So what they use a chart, right? And so this is one of the charts here. But this is the most common chart that they use, but they have a couple of them out there, right? This is called the Stockholm's scale. Look at here, the Stockholm scale. I think this is what the Western world uses, Trinidad, the Caribbean, America, England, but China have their own, right? It have other charts out there then, right? But I think we would have to say the Stockholm scale. And if you look at it, it's a scale on 1 to 5. If you look at the fingers or the hands here, it's a scale of 1 to 5. And it goes then like, when they say the early stages is like stage 1. This is where just one of your digits start to be affected then, like with slight tingling, right? 2, where, and of course there may be some decolorization, may start to become a bit blanch or white. Stage 2, right? Then it means, okay, like more whitening, more numbness, more blanching. Stage 3, stage 4, stage 5. Now, some of the later stages, but it's kind of hope that nobody ever reaches that then, because you wouldn't be in such pain. You understand it, folks? You wouldn't be in such discomfort, or you shouldn't be in such discomfort in this modern age where your finger hurting you and you're bearing all of that pain, right? So it is hope then that it never reaches into stage 4 and stage 5. But if it does, it would end up in amputation, right? So if I can go back here, you see the early stages, which is like stage 0, right? Condition of your digits or condition of your fingers, no blanching of the digits, no complaint. And you have different stages of 0 as well, right? So stage 0 and intermittent numbness, right? T there, intermittent tingling. Stage 1, blanching of one or more fingertips with or without tingling and numbness. Stage 2, blanching of one or more fingers with numbness, usually confined to winter. And of course, they recommend what should have been done here to the workers anyway, right? Stage 4, extensive blanching, most fingers, frequent exposure, summer and winter, right? So you understand when they say at the early stages, it's stages then on the Stockholm scale. So I wouldn't bother read this because I explain it to you. Think you okay with that? Yeah? So that you understand what we meant there by the early stages and the later stages, right? I could probably try to pick it up somewhere here if there's anything. Let's see. During the attack of the numbness and the tingling in your fingers, right? The fingers have reduced sensitivity to temperature changes, pressure, and pain. Reduced dexterity from loss of muscle control causes clumsiness in handling small objects or doing simple tasks like button fastening. Continued prolonged use, so, you're still using the tool, which it shouldn't. I mean, this is, 2025 anyway, right? So the condition generates the cyanosis where the fingers take on a blue-black appearance and may become permanent. It's hope that nobody ever suffers that much in this generation anyway. In extreme cases, gangrene may occur and amputation, the only remedial measure. Right? How it happens biologically, or what they call the pathology, is not well understood. Simply put, different people are different. Your circulatory system, your family, your family record of circulatory illnesses, right, may be a problem with this as well. Some people may use that same tool and not have that effect that you are having. Some people are different, right? So they say the pathology is not well understood, but related to a lack of blood flow to the fingers caused by abnormal conditions in the small arteries. Microscopic examination of finger tissue, people had it amputated, right, has shown that the small arteries become blocked. Muscle enlargement is a typical response to exposure. Reduction in sensitivity indicates damage in nerve endings. Neutral activity by the whole arm has been reported, indicating reduced nerve conduction or the speed of nerves then, passing from one part of your body to the other part. I don't know if I have time to go into that, but that's like a synapses, if anybody remember that thing anyway, right? There's little evidence to show that recovery from vibration white finger occurs when exposure ceases. So what that means is that this is a chronic condition, right? Report indicates recovery is only slight and very slow. And then you may have to go to some of these sound therapies I was talking about to kind of do something for you, because medically they can't do anything for the arteries and the capillaries and stuff like that, right? So several scales have been developed. We mentioned the Stockholm scale. Please remember, several scales have been developed around the world. I mentioned China have their own, but I think the Western world uses the Stockholm scales anyway, right? These are some other tests that could be done. A sensitivity test, a doctor could do that on your hand to see how sensitive, maybe touch it with something hot or whatever have you, or cold provocation tests, like try to get you to touch a cool object. All of those are really more tests, but I don't think all of those are covered in this course anyway, right?
One question.
So,
If this affects the arm and fingers, does it affect the foot as well, feet and toes?
that's a good question. I don't think so. I mean, like in my study, as I said that day, look at that. I think the thing is called vibration, hand, like hand-arm transmission, right? So I don't think we ever look at like vibrating
Because
effects to the hand, to the foot. Yeah.
Because from experience out in the industry, I've heard a couple employees complain about some of these symptoms within their feet. So that is the reason why I asked the question.
I think it's a good question. But I don't think any studies have been done, and I am not in the position to see them. But like the only thing I can stretch it to be is, like there are lots of literature on this, like the thing is stretch it to be is if you talk about, like the whole body transmission. But whole body, if you look at this slide, doesn't really link to the feet, is more linked to the back pain, disc-related problems, right? But I think if somebody does have Trinidad, we have people, and of course in the colder countries as well, with circulatory problems. If you already had a problem with your feet and you are standing on a vibrating platform, I think it could have. I think that's obvious then, because remember, vibration enters your body. Sorry, vibration enters your body in the three planes, so you're getting it in your feet then, right? So I think yes, I would say, but that's just what you call an educated guess, right? Like that's just saying that someone is on a vibrating platform. I'm sure you all have seen them. I have seen them, right? There are people who stand on a platform, like based on what they do now, the whole thing is vibrating. If they do have circulatory problems, I think it could affect the feet as well, right? However, I would say that's probably some studies that have yet to be done, because most of the studies link whole body vibration, not to the actual instep of your foot, if that's what you're talking about, like the toes, and the toes becoming white. Most of the studies have linked whole body vibration to back pain, slip disc, right? Those kind of things that are not really the actual toes. So maybe I'll leave that for you all if you all get onto your masters. You wouldn't find the problem with that, it mightn't have literature to support it. Again, your literature may be the only one trying to make some kind of link then between vibration and the effects to toes, right? The effect to your toe and the instep or whatever have you, right? But like I could say that no such study I think is out there in a massive quantity because I didn't come across them, right? They may be there, but I think like what we were trying to do there, Shaliza, was to establish if Trinidad and Tobago wasn't like breaching the figures then published a hand transmitted vibration and whole body vibration, right? So like I didn't look at workers' feet to be exact with you. I can't remember doing that. And most of the studies didn't do that too. But I think it's a nice thing to look at. If I mean for people who do those kind of studies, what that means is that you would be recognized now. Then if you know that, your work in the future then would be the one that makes it to be like, okay, that makes that link. And that's a good thing. That's such a good thing. Maybe somebody could have done that and create that kind of link anyway, right? I would probably suggest, though, based on what I came across, I just saying this, you never know what the future could hold or where you all could end up with your studies, right? That you may want to kind of get your studies outside of Trinidad and Tobago and outside of Guyana, outside of the Caribbean, and because the heat, our temperature makes it difficult for these things to affect us, then you probably have to study machine shop workers in a cold country or something like that, right? But I think that's an excellent point. Um, I think it's a good thesis, master's dissertation, if anybody had that, or when that time in your life come if you're doing a master's anyway. All right.
So
Go
let
ahead.
me ask one question again. The whole
So,
body vibration. Why the effects of it is only attack, or not only, but mostly attack the lower back region?
I think that is what I mean. I could probably say it have to do with what they call the pathology, which is not well understood. That's where the effect is. I do suppose too that like how we did, like this is the pathology for hand vibrations. So I suppose it's a similar effect. Like when they have studied all of these workers, maybe rather than have to do with the fact that the back have 33, bones, vertical bones, the vertebral column. Maybe those things are, as they say, linked by how do you call it? A cushion, like a disc, like the spinal disc, and maybe that vibrating platform at somebody's on, the vibration is actually affecting the spinal bones then, as opposed to other parts of the body anyway. That's how the
Because
pathology
I,
is. That's how the
I don't
vibration
know.
enters the body. Yeah.
I
Yeah.
don't know. I was just thinking about in terms of that the equilibrium point at where the vibration from up to down. Remember, I don't know. I just thinking along that line why it will affect that point in the body.
I wouldn't be able to say, again, I would be able to say, well, we know vibration enters the body in three planes, which is our 3D plane. Well, we are a 3D being, right? So maybe the effect is at our core, which is, at the back there anyway, right? But they do have other effects, and as Shaliza mentioned there, like one of the effects of whole body vibration is frequent urination. Like you feel like a truck driver then or a forklift driver, like you feel to go to the washroom often. I suppose there are other soft effects, right? Like acute effects then. But to say if anything has been sort of published too much on that, other than the known areas of the body that are affected then, I don't think much have been, okay, like they have your digestive disorders, urinary problems, abdominal pain, digestive disorders, if I didn't read that one already, balance, it
But
affects your
so
balance. Uh-huh.
you notice all them symptoms is within the middle of the human body,
Yeah,
right?
but what about headache? Headaches, visual problems, right? Again, these things would have been based on studies. It would have been based on target groups. Nicholas had that in the comment there. Um, like we don't know that. Like you don't know when you read these things, like what the worker was suffering from. Suppose they had already a digestive disorder, but because have you all seen them in machine shop, folks? I remember working in a machine shop. This is just based on my experience, and don't laugh. One of the guys, he lives in, well, the village I used to live in, right? I used to see this man. They used to call him, well, his name is Preston, but they used to call him a different name in the company. So I wouldn't call I wouldn't use the name we used to call him, but his name is Preston, right? I still see Preston, right? Um, this man, this was IEL, Industrial Agencies Limited, and well, not coffee, and crossing where the burger carts, where you have all those burgers and all of those food places there now. IEL is now turned into Tucker. Well, IEL was always Tucker, right? IEL was always owned by Tucker. Anyway, I would see these workers come in the morning, they clock their card, Preston was one of them, and they go, it was like a big machine, or like a big machine, and they go on the platform, but the machine that was on, and the whole platform would have been vibrating, right? And break time, folks, was kind of robotic. That's what I couldn't understand. It's kind of robotic. Break time, they will clock their card, they will come out. After break, they clock in their card again, they go on back in the machine. And that was their life. And I remember thinking one day, like, what's in them fellas and them do? Like what's in them do? What's in them do, right? To get a job like that. But they never complain. I think everybody's different. Everybody kind of know what they like to do. But to me, I was like, mentally, I cannot do that. I cannot just stand up there. I mean, other than your break time and your lunchtime, for all the hours of a day, right? And that's what they used to do, right? And that was a mission type setting anyway, right? But people do work like that. People do work on vibrating platforms and whatever have you, right? Of course, the bigger rigs and whatever have you offset. Like once something is on, then there's a measure of vibration created in it anyway. So exposure to whole body vibration. Did I finish the other slide? Let me see. No, I didn't, right? So let me read this one. Vibration-induced white finger associated tools and processes. We have pneumatic riveting, caulking. If you don't know what those terms are, that is like that's like sealant. Like if you put a sealant around a metal surface and you're trying to kind of like grind it off, that's what they call caulking. Like epoxy, resin, whatever you're familiar with, right? Fettling. If you want, I could tell you what the words on it mean. Fettling is like if you do like a welding and then you come back and you're trying to grind off the tough part of the welding, or like the welded joints. That's called fettling, right? The others you don't need explanation, right? Hammering, drilling, chipping hammers, chainsaws, concrete vibro thicknessers, right? So like all of those may be used to level the surfaces then, right? So they create a certain measure of vibration on them. If you're using a fettling, you can actually use a file, if you know what a normal file, right? To file down rough edges of a surface. That's called fettling. But most of the times they use like a grinder then, right? So like it have small ones, it have big grinders, it have small grinders, right? But again, once the machine is on, remember the vibration is getting to your hand, right? Tire rims that are cracked, Masha has a good point. One's core is directly affected by vibration due to the center of gravity. I suppose so, Nicholas. I suppose so, yes. I suppose, yes. Yeah. Now, just thinking of a lot of the medical benefits of vibration too now, right? So like, yeah, I suppose if you're using a tool, yes. Of course, if you are taking some kind of therapy, I suppose the answer for that is also yes, right? So exposure to whole body vibration can affect health, comfort, and work performance. The principal health effects associated with whole body vibration are back disorders, back pain, disc-related problems, as in disc between your spinal joints, osteoarthritis. In some cases, the causation is poor posture. Other problems alleged to arise from exposure to whole body vibration include, they say alleged here, abdominal pains, digestive disorders, urinary problems, balance, headache, and visual problems. Again, all of that may be some kind of other history of the person, but then that's the effect that they are going through. Like somebody like me who suffer from migraines, headache may be more of a problem. Balance is not a problem for me, whatever have you, right? However, a causal link has not been firmly established, and that is what we call confounders, because people have so much of other things that affect them, right? So whole body vibration can affect work performance by interfering with visual processes and the ability to assimilate visual information, hand or foot movement, and the ability to control equipment. Whole body vibration is more difficult to specify as an occupational problem. Health effects tend to be less specific. Health effects tend to be indistinguishable from the other causes that may have already been affecting you. Vulnerable groups would include those with degenerative back disorders. Typical work activities of at-risk groups include drivers of heavy vehicles. You can read the rest, right? Tractors and whatever. Forklift truck drivers, operators of heavy machines, power presses, aircraft personnel, train drivers. Again, they are sitting for a very long time as well. Well, not all the time, right? A lot of trains in the UK now are more or less automated, right? Identify group of workers at risk from hand arm vibration, including some typical activities. Well, I think I said it when we talked about things like anything that includes grinding, fettling, anything that includes, but you using a machine by hand then. Because like, could you think of anything applicable like around the home, like any like machines that people use around the home? Because I'm thinking about a couple as this is here. What type of equipment around your home could, like homeowners would use then that could also give rise to vibration? And would you believe that those equipment actually have the vibration magnitude mark on it? If you go back and you check it, you'd see. Very good, right? So the waka is one of them. If you look at a waka, if you look like, like that, you'll actually see the hand arm vibration is actually specified on it. And it's not greater than 2.5 because remember, 2.5 is one of the action levels anyway. In fact, it shouldn't be more than 5, but kind of complicated. Remember, the UK gave it two figures. One is for 15 minutes of use, that's a 2.5, and the other one is for 8 hours of use. So after 8 hours of use, you shouldn't cross 5 meters per second squared. I did tell you those figures are coming up on the slide. So it still is coming up on the slide. Let me try to clean some of this. Anything else? If you use a hedge trimmer.
So I now got to ask that question concerning heavy equipment. And it's supposed to have the length of time is supposed to be using it for vibration.
Yeah.
And well, basically the formula of it, and that will fall under ergonomics because the design of it and how long it should be working.
Yeah, but when I say the manufacturer will publish on it, try not to jump this slide. I guess I have to jump this slide because of the question, right? Like if you measure, when I say you or a company, by the way, too, your phone could do it, but I don't know how good your phone will measure. Actually, your phone will do a good job now. I don't know if you know that. Your phone actually have a transducer in it. What is a transducer? A transducer is something that measures in 3 planes. That's why if you turn your phone, the picture will turn with it as well. The phones have a transducer. So it may have an app. I don't know for sure. I just guessing, right? It may have an app that say that it may have an app to say that could turn your phone into maybe a hand vibrated meter. But the point is here, if you measure a tool, the truth is I don't think your phone will do a good job. You know why? It may, but I don't know. I really don't know, right? Because how they measure hand vibration is like something have to connect to the tool and connect to your hand. So if this is like, I guess, how do you draw a waka? If this is like a waka, right? There's something connecting to the tool and there's actually something connecting to your hand, right? There's like instruments then. There's like, they'll have, like, what the person hand is, somewhere up here, I guess. So they'll have wires then. They'll have like a wire connected here, sensors connected to the tool, and then they'll have sensors connected back to your hand. So that's how I don't know if the phone will be a good. Remember last week we say there are apps you can use to convert your phone to like a noise meter, but I'm not too sure for vibration, right? I'm not too sure if those kind of apps have been developed. But anyway, if you do measure, let's say you get 1 meter per second squared, that remember vibration is meters per second squared, and you had measured for 15 minutes, let's say you measure for 15 minutes, well then you are good. You are good. That tool is good. The manufacturer did a good job. They created a waka that is kind of, reduction in sound, reduction in vibration. You are good because remember what I said, the law says for the 15 minutes, you're not supposed to cross 2.5 meters per second, right? So for the law, 2.5 meters per second. If you measure and you get 1, everything is good. Again, all of these things could be reality with a past paper where they tell you like they measure three instruments and they got 1 meter per second, then they got 3 meters per second, then they got 4 meters per second over 50 minutes. And then if you want, I mean, you want to write it down. I mean, I've seen it so much at times, 2.5 over 50 minutes, and then it's 5 meters per second over 8 hours, right? So you're not supposed to cross those two things. Those are the figures, a hand-arm transmitted vibration, meters per second square for them. 2.5 ms to the minus 2. If not, wait a bit, it come up on the slide. It have a table with it already on the slide, right? Okay, so thanks for taking part in terms of giving the answer for that one. Anybody thought of any piece of equipment again home? I suppose anything that your hand is in contact with. What about a treadmill? Right? I mean, I suppose all of that, if in contact with a treadmill, right?
Yes,
Which
sir.
one, Marsha? Yeah?
Sometimes these same home equipment can actually have positive benefits pertaining to the body itself, right? For instance, from gym, the fellas know that when you go too hard, sometimes you can't put your hand straight down. It tense up within a 90-degree angle. Now, using vibration itself, it could help relax the muscle for you to
Yeah.
have that form of flexibility. And back in the days, I've noticed that they had some commercials with those ab pads. It caused vibration within the abdomen to strengthen and build muscle within that area too.
Yeah,
So
I remember
sometimes
those. Yeah. Yeah.
it really depends on the area that you're using it and for, like you said, the prolonged period of the usage for it.
Yeah. I mean, for those who know me or really know me, remember, I don't live in health and safety, right? I know some people don't believe that. But I think you all know me well enough, man. I mean, I've shared so much of things with you all that I do anyway, right? So like if I'm not in front here, I'm in the park. And if I'm not in front here, I'm cycling. If I'm not in front of a class, I'm cycling or skateboarding or something, right? But like one of the things that I am fascinated with is like that. I've said that to you all for noise when I did noise. I'm fascinated with the idea of like the medicinal benefits now of like sound and and things like frequency. Have you ever come to the office? Have you ever come to the office? If you look up at the TV right now, the flat screen, I have a sound on. I normally have like sound. When I say sound, like just music, background music on that at certain frequencies. This one right now playing, let me tell you, this one, okay, they didn't mark out the frequency for this one. Like sometimes they do, right? Sometimes they do. Like I have one here, 432 hertz, right? So I'm often that's part of me. I kind of like me, I like safety, but I like health as well. There are a lot of people who don't know that the thing is actually called health and safety now. But safety is what have the money in it. Safety have the money, but then you need to take care of your health, right? Because what good is money if you don't have good health, right? So I don't know if you all know, do you all know that I actually have another degree? I have 3 degrees, I actually have 4. I sometimes don't talk about the last one, which is actually a master's in health, but not public health, but like sort of like health, like your health of your body, right? Like how to take care of yourself and stuff like that, right? So that's why sometimes like when I teach these things, I know it's academic, but I know it have other medicinal benefits to it now, right? And you could do the same. If like you have a task to do, just put on some quiet frequency music to the background. It helps a lot, right? Those things do help. It is proven, like I said, it's proven with microscopy. You can actually take, a picture, X-ray. You can look it up. All of this research have been done in terms of, sound and sound vibration and what it does to your body, etc. So you may find it coming on because I have a degree in it as well. I normally don't get to say anything on it, except if it's a class like this, right? Except if it's a class like where something is kind of similar to the two things I studied. Other than that, I don't talk about those things at all, right? But there is that science out there. I think there's lots of money in it as well, but probably not for me because I am more the safety side of it. But if anybody, I've seen people getting into things like sound healing and how Oliver mentioned they're like a healing, like a sound mat, right? These things selling it. These things sell. These things are the quickest sellers right now on Amazon. The quickest seller right now is anything about health because the world is not taking care of itself, right? Everybody's studying to just run production, production, production. But like I said, the good news is it's health and safety. The health part of it, though, normally does get ignored a bit anyway, right? But you don't ignore it.
Yeah.
You don't ignore your own health. That's what I'm trying to tell you all. Right?
And if you look at most Chinese vehicles that are built right now, sir, most or all of them, they're including the whole massaging, seating, and so on
Wow.
within it.
Yeah. Yeah.
So they're
Yeah.
actually
Yeah.
taking the approach towards at least you're sitting for a long period of time. You need certain circulation within the muscles and so on, so they can implement that
That's such
massage
a good idea. Yeah.
feature.
Yeah. Yeah. You know, and like I said, I think for you, not for me, because I don't see myself getting involved in that science, but I think there's money to be made in that health aspect of it. I saw somebody recently, just to give you a funny one, I saw somebody selling what is called an earth mat. An earth mat. What is an earth mat, right? Um, I think they say an earth mat is like for those who live in apartments and those who live in the developed countries where you cannot touch the ground. You can take off your shoes then. They say there are benefits of taking off your shoes and just standing in the dirt or standing in the earth, right? So like people who can't do that, they sell them on earth mat. You can go on Amazon and check it. It's sold out, right? Those things have money in it. It's sold out. Those things are what, it's not about safety. It's for, like developing countries, Trinidad, Guyana, but there's also the health aspect of safety. Like I said, I think that part of safety has not been fully tapped into. Like there's no too much of NEBOSH health courses, but there could be. And I think that's where the future will go in terms of health and safety anyway. Yeah.
I'll give you a joke, sir. Back in 2017, I went through the province of Guangdong, China. And because the toilet paper factory district is like, let's pretend it's about 4 times the size of Trinidad, right? It's like a factory area. They sold air in cans for about 10 US a can. And
Yeah.
that was part of their health and safety requirement being there. Every couple of hours, you'd have to purchase a can of air to breathe.
Okay, then. All right. I actually saw that once upon a time on an old Twilight Zone movie. Well, Twilight Zone episode. But is it really just an empty can that you purchase it?
No, the can has like they have all their approvals. Obviously, everything's in Chinese, but they'll give you like a certain amount of time on the can. So you'll buy like 15 minutes of air or 30 minutes of air, and between every 5 to 10 minute interval, you'll have to take a couple puffs because the air quality within the toilet paper factory district is pretty terrible in that province.
Wow. Okay. 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 Wow. Yeah, I did actually. I saw that on a weird Twilight Zone episode once. I don't know if you all ever saw that. Yeah, but I mean, who knows? Maybe the earth wouldn't get that bad. That's why the earth is that polluted. They really had to sell air, right? All right, let's move on with this a bit. Cleaning some of the slides. So folks, if we don't get to finish based on the time in here, I would probably ask you all to do some read up on this, right? Group of workers at risk, vulnerable groups. I think that does said it. I think that says it all, doesn't it? Right? I mean, the heading says who could be at risk, right? Let's just look through it a bit. So in addition to the general group or the generic group of work activity and equipment, individuals may be vulnerable to continued exposure of vibration. Those who have existing hand-arm vibration syndrome. It was actually called Raynaud's disease, but this is actually a disease that affects circulation as well. Peripheral vascular disease, including smokers. They say smoking contributes a lot to vibration, white finger. If you have any sort of nerve problem, history of injuries, whatever, right? History of blood circulation. So I think the heading was the answer now. Those who have pre-existing conditions could be at a risk of it, right? So finally, I think to the lower, I mentioned this all before, the Control of Vibration and Work Regulation 2005. 2 limits are published. We have the exposure action value and one, well, there's only one limit. You can have 2 action values as in noise, but they only have one and they have one limit value, right? So I wouldn't go through all of this again. We mentioned that vibration enters the body in 3 planes. The instrument used to measure it is called an accelerometer. It actually measures the 3 planes by the use of a transducer. I also said your phone have that in it as well, but I'm not sure if your phone could actually be held in your hand. But then how are you going to connect it to the equipment? I'm not sure, right? So we did also say that vibration affects at the lower frequencies, the 5 to 150 hertz range is what could cause the vibration-induced white finger, right? This one is about measurement. When you know they normally take measurements over 2 periods of time, 50 minutes or 8 hours. And then the equipment will do all the calibrating for you. You hear they say they talk about the weighting system again. So they actually kind of weigh it as again, like weighing it means they're adding or minus and a number from it. But you don't have to worry about that. The equipment will do it for you. And what did I do there? Let me see something I did wrong. I think I clicked the wrong thing. Right? Long ago they used to measure, we used to have like a rough scale to measure it. This is one of those scales. And there was also like a tip, but this is still the typical thing you may find. Is the slide changing for you all as well? I thought something just now. Like I also seen a schematic of an accelerometer in the background. Okay, good, right? But I mean, there are no such questions. You have the accelerometer. This is in the inside of it, preamplifier. They will weigh, they will add or minus a figure for it to bring it back to a whole number. Time averaging, either the 15 minutes or the 8 hours, and then you get something on your display, right? This is actually, again, kind of like the one for noise called a nomogram. They used to have to read this off. Like when I say read it off, it's not hard. You just take a ruler and you kind of, you take a ruler and you sort of correspond. This is the acceleration here in meters per second. If you got 20, you correspond that there, and you correspond it again, and you get your value. But today, as you all would guess, and we have said this before, very similar to noise, the HSE has also developed an online calculator for that. So the vibration nomogram, this has been replaced. It's like an old way of testing it. They have replaced it now with the vibration calculator that you get from the Health and Safety Executive website. You remember seeing one for noise last week? There's also one for vibration, right? Sorry, this picture look a little bit blurred, but that's because I blew it up. Maybe if I could bring it back down, it may look a bit better. But the point is, you just have to put in the vibration like level. You put in your time, and you just press enter, and it will work out the daily exposure of vibration, and then you just measure that up with one of the figures above the law, right? If the company is in breach of the law, or if they are still within the remit of the law, right? So let me go back to the slide with the law in it. You'd see, so you'd see the law for hand arm vibration is 2.5 and 5 meters per second squared. For whole body vibration is 0.5 and 1.15 meters per second squared. Right? So these are the figures. Well, I mean, remember you all don't have to really learn nothing by heart. You can open up the slide and of course just get back the figure to see if the person is within the law or they need to take action. Remember, action values mean to take action, right? So that's actually on the slide too. If you measure and you get 2.5, it means you have to like maybe turn off the machine, maybe fit it on a dampening stand, maybe put a rubber mat under it, possibly give the worker gloves, probably do health surveillance on the workers, all of these to avoid crossing the limit, because once you cross the limit, you are now in breach of the law itself, right? So as with noise, the harm from vibration results from the duration and magnitude of exposure. Different exposures are compared using an 8-hour average called the A8 value, and then what you get is a daily exposure level. Right now, they also have the way of calculating noise using a point system. So I don't know if you all wanted to see this, so I'm just looking at the time as well. You want to have a look at page 217 if you have your book? I was just sending a guidance in it, but I didn't open up the guidance per se. Right? We could just use the one from the book if you want, right? And so there is a ready reckoner for noise and for vibration. So the ready reckoner is like a table you have to correspond. If you have your book, you can get it on page 217. The calculator is on page 218 in your textbook, but I know this is blurred too, because it's blurred because we sort of enlarging it now, right? But I think the essence of it still is true, which is if you're looking at using the ready reckoner, you could probably say this is 5 meters per second squared. If they say a worker was exposed to vibration of 5 meters per second squared, let's say this looks like 3 here, right?
It is also very blurred in the book, eh?
It blurred in the book
You're just
too.
seeing a few
Yeah.
of the numbers on the book itself. Nothing
Okay.
is
But what you could do then is download the guidance on it. I think I sent you the guidance on the email too, right? You want to download the guidance on these two things. And so what they do, it just corresponds. And if it's 5 meters per second squared, and this is 3, let's say this is 3 hours, right? You just correspond it and you get a point. So the table shows you points, right? So if this is, let's say 120 points, what that would mean then, because on the point system, on the ready reckoner system, 100 points, right, mean that you cross the exposure action value. And if you go back to the slide, 400 points mean that you cross the limit. So if you use the ready reckoner system and you got 120, they could ask, what does that mean? That means you have crossed the exposure action value. So you need to take action before you cross the exposure limit value. And in the point system, in the ready reckoner tables, is given like a point system, 100 to 400, right? From what I remember last week, just to re-emphasize something last week here, I think the ready reckoner system is off the syllabus. This is off the syllabus, right? Last week when I opened the syllabus, I think I showed you all that. I started with that. Today I didn't start with the syllabus, and my mistake there. Just I wanted to see how far we can go, but you all could open the syllabus for yourself, right? The ready reckoners, this what you're looking at, this that seems to be blurred then is actually off the syllabus. What is on the syllabus is the calculator, where you just when you put in the noise values, you press enter, and you get your daily exposure level. So these are some of, this is still in your book, but it's off the new syllabus, right? But I'll leave it to you to probably go and see if you can download the Ready Reckoner, right? It's not difficult. You just correspond vibration and time, and you get a point, and then any point lands somewhere between here, 100 or 400. But I know it's off the syllabus, right? And what's on the syllabus is the HSE calculator, right? So it didn't look as if we're going to finish, did it? Right? I thought I was going to finish when I started, but I don't think so. Let me see how much. I wouldn't raise anything else then, right? I think the rest of this, and if I could have asked you to do some reading on your own, it's about less than about 10 more, 20 more slides, right? But the rest of it is actually on control, right? Like how do you control, like vibration then, right? Like I have a guidance here. This is the guidance I emailed to you all, L140. Practical control measures to prevent or minimize exposure with reference to L140. That's an ACOP. I think the syllabus in particular mentioned part 2 and part 3, the advantage and disadvantage of using wearable technologies. And that is, if you leave it to the slide a bit, you'll see it in a bit coming up, right? Hand-arm vibration, or HAV, is a widespread hazard for employees in many industries and occupations. This second edition of L140, that's what Sani outlined what an employer duties are under the Control of Vibration at Work Regulation 2005. I have some on this slide, right? As they relate specifically to hand-arm vibration, HSE publication L141 deals with whole body vibration. If you want, so some of these are the wearable technologies, right? If you want, I could just show you some, right? I duplicated some here, but in no way did I duplicate the whole ACOP on the PowerPoint then, right? Let me just start this a bit and I'll show you some of them. Very easy, very, very easy stuff, right? Straight read. Look, one of the ACOPs here, right? Straight read, straight things for you to do, right? So, folks, even if I'm not going to get to read all, what I'm telling you, the controls are here. We try to touch some of them, right? Let me just try to touch. I'm going to touch a bit of them, right? I'll just choose one in everyone to read about anyway. So L140 Part 3, what is health surveillance? Health surveillance is a program of systematic health checks to identify early signs and symptoms of diseases or disease and to allow actions to be taken to prevent its progression, right? So according to the ACOP and stuff, higher company field testing. So if you have like a hand-arm vibration policy, buy only low vibration plan for hire, making the decision for their customers based on direct comparison of their own field vibration levels and other operational factors. Provide customers with field vibration data for all hired plans. So again, a policy here then is to buy the tools then that produce less vibration, right? This policy involves additional investment in training, instrumentation, and time, but has been directly responsible for the success of the company in gaining a large long-term contract with major utility companies, right? There's a case study here. This is like how you'd see they put the thing to measure vibration, the accelerometer then, right? There are links to the person hand, and then there's a link to the machine to really get the hand-arm vibration figures anyway, right? You see another picture of it here as well. Not any person headed, this is just the person, goggles there anyway. We're looking at what is here anyway. So the sensor on the person's hand connected to their hand, and then there are those on the piece of equipment as well. All right, some controls are just touching it fast. And manufacturers are under increasing pressure to develop low vibrating plans. In this case of a prototype, redesign low vibration handles reduces the operator exposure during simulated cut-ins from 5 to 6 meters per second squared down to 1 to 2 meters per second squared without affecting the mower control. This is somebody using a remote control here. If you notice this one now, this is a very good answer. Remote control vibratory plates. Like a roller then. There's remote control. In this case, the person's hand is not on the machine at all. They are just controlling the remote, right? Problem here, this is extensive fettling. This is how they're going to try to grind off the rough edges here. They're using a rotary burr, produces 2 meters per second squared over a typical working cycle. What they did here though was that they changed it out from this sort of grinder to like a belt, like a sort of conveyor grinder. Belt grinders, they say they change over to belt grinders for most jobs. These produce only 0.5 meters per second squared. However, though the downside is that it's kind of costly. I mean, this is very costly, isn't it? 700 pounds, that's 7,000 TT, little less than 7,000 TT. So I guess a company have to have money to get into a measure like that then, right? Here they have vibrating like a abrasive wheel linked to this machine here. They said the vibration was very high, about 32 meters per second squared. The solution was to have this on its own separate stand. Don't have it linked to the machine, right? And then it went down there now from 32 meters per second squared, just about 1 meter per second squared, because this is, of course, stabilized to the ground, right? As you read the rest of it, if you read the rest of it, you'll see it have lots of controls here. See, like this is only guidance, right? Encourage good blood circulation by keeping warm and dry. Wear gloves, hats. So this is very good for your exam. When they ask you what are the controls, right? The guidance is normally have it. Giving up or cutting down on smoking, as smoking, reduces blood flow. Massaging and exercising your fingers during work breaks. What else should I do? Recognize the signs of vibration injury. I'm picking some, right? See if the work job can be carried out in a different way. Choose tools and equipment which have low anti-vibrating features or vibration features. Wear gloves, keep warm, ensure good circulation. Only use sharp tools. Do take regular breaks from the particular task which give rise to vibrating risk, right? So a lot of the answers you all know are on the guidances. This one is the same thing, right? Can I have a read of this one? This straight from the HSC. If employee no longer fit, consider alternative work without exposure to hand-arm vibration. If the employee is fit but have hand-arm vibration syndrome, consider reducing exposure, taking into account any advice and restriction, maybe from a medical practitioner or a doctor, etc. Right? So what I will do, folks, I will not continue vibration next week. I'll leave you to read out the rest. I think the overall team is there. And I think, we would move on to radiation next week to stick on target, right? Remember, we have radiation and we have manual handling. By April, we should be wrapping up, and then May is your exam, right? Do not forsake your book. I mean, we spoke about those things before. Don't forsake the guidances and right? In terms of your study. Next week, too, I want to try to finish off radiation in one go. I think what makes it a little bit tough in the beginning is the physics and stuff now, right? I know those things too. Having spoken about them, I know too that they are not going to be examined, right? Next week is the same thing. When you start radiation is different types of radiation, wavelength, frequency, and stuff, but those things are not really examinable for your course anyway, right? So let me stop here without any further ado again. If I did not see your comment, it was because I was teaching, right? Yeah, some of you all seem to know what I was talking about in terms of, sound and stuff like that, right? Do of course look into those things. I think those things is what make studies interesting. Studies is not just your book then. I always look at what is the most interesting thing in what I'm studying to make it interesting for me anyway, right? All right, let's call the roll. We have RT.
Yeah.
Thanks very much. Do enjoy the rest of your Saturday, folks. Carrie Ann Green. Dear Raj. I don't think he's in. Nicola Shelby. No. Nicholas is here. Michael Lewis.
So,
Okay, good. That's Nicholas, right? What about Michael? Michael Lewis.
yes, sir.
Okay,
Yes, sir.
good. Okay. Marsha is here. Mukesh. I'm seeing Mukesh name there.
Yes, sir.
Okay, good. Oliver is here. Pooja is here. Janelle Duncan is here.
Here.
Okay, yes. Jalen George.
Yes, sir.
Okay. Adisa Knights. Durban said he couldn't be here today, right? Narendra said he couldn't be here. Surendra, I think I know you are here. You came in the first person today.
Present, sir.
Yeah. Alana Singh.
Yes, sir.
Thanks, Alana. Romel Frederick. Ijaz Ali. Ronald Whiskey.
Yes, sir,
Ronald is here,
present.
right? Yeah. Shania is here. Shanice is here. Alex is here. Right? Mahalia Alexander.
Present, sir.
Shaliza is here. Roderick Carrington. Stacy is not here. Dexter is not here. Ria is here. Shival. Farid. Kumar. Kalista. Okay, I think I got the rest of you all, right? Folks, you enjoy the rest of your day. Ria, I got you. Shanice, I got you as well, right? So you enjoy the rest of your day, folks. I'll see you all back next week, Saturday.